Hello viewers, today we will discuss some of the world problems involving linear equations. Now what these world problems are? The world problems are practical problems and involve relation between known and unknown. And these world problems are often stated in words and can be mathematically formulated. Let's see one example. It goes like this. In a fraction, if the numerator of a fraction is doubled and denominator is increased by 3, the fraction becomes 5 upon 6. But if the numerator is increased by 3 and denominator is doubled, the fraction becomes 4 over 9. Find the fraction. Now, while doing these problems, you have to take care of some of the things. What are those? First of all, you must read the problem carefully and note down what is given and what is required. After that, denote the unknown quantities by the variables. After reading the problem carefully and denoting the unknowns by variables, translate the statement of the problem step by step into mathematical statement. Later, look for the equal quantities and write the equation by writing appropriate expression. And finally, solve these equations and check whether the solution satisfies the given conditions or not. We have a short while ago narrated one problem. Let's have that problem once again. In a fraction, if numerator is doubled and denominator is increased by 3, the fraction becomes 5 over 6. But if the numerator is increased by 3 and denominator is doubled, the fraction becomes 4 over 9. Find the fraction. Now you know that in a fraction, it consists of numerator and a denominator. And for the fraction which we are talking about, neither the numerator nor denominator is known to me. So what I will do? I will suppose the numerator to be x, and now here x is a variable, and denominator to be y. Now the next condition with this was that if the numerator is doubled. So the fraction becomes x over y. Now when the numerator is doubled, it will become 2 times x. So that on doubling the numerator we get 2x, and denominator is increased by 3. Denominator we have supposed as y. So denominator now becomes, on increasing by 3, becomes y plus 3. So what this fraction becomes then? The fraction now becomes 2x upon y plus 3, and this is equal to 5 upon 6. Now having got this, now we will simplify this statement, this mathematical statement. Now have a look at that mathematical statement once again. This is 2x upon y plus 3 equals 5 upon 6. So on simplification, this will become 6 times 2x equals 5 times y plus 3, and that gives me 12x equals 5y plus 15. Now transferring this 5y onto left hand side, I get 12x minus 5y equals 15. So from the first condition, I got one equation, and that equation is 12x minus 5y equals 15. Now there was another condition in the problem, that was when the numerator is increased by 3. Now what was the numerator we supposed? Numerator we had supposed as x. Now when it is increased by 3, it will become x plus 3, and denominator is doubled. What was denominator? That was y. So on doubling the denominator, it becomes 2y. So, therefore, the fraction will become x plus 3 upon 2y equals 4 upon 9. Now, this is an equation involving two variables x and y, which can be simplified as 9 times x plus 3 equals 4 times 2y, and that is equal to 9x plus 27 equals 8y, and on transferring this 8y to one side onto LHS, we get 9x minus 8y equals minus 27. So, now we have two equations from the two conditions, and these equations are 12x minus 5y equals 15 and 9x minus 8y equals minus 27. Now, you have already learnt how to solve them graphically and algebraically. Now, it is always not convenient to solve the equations graphically. So, in most of the cases we follow the method of solving the equations algebraically, but keep in mind, in case in your examination it is asked from you to solve the equations graphically, then you have to solve the equations graphically. Now, let us solve these equations. Here I decide to find the value of y first. So, that means the first equation is 12x minus 5y equals 15 and 9x minus 8y equals minus 27. So, for that I will have to make the coefficients of x same. For that I will multiply the first equation by 3 and second equation by 4. On multiplying by 3 first equation, we will get 36x minus 15y equals 45, and second equation by 4. So, that also makes it 36x minus 32y equals minus 108. Now, since the coefficients of x are same, that is 36 and 36, and both are having the positive sign, what do? We subtract the second equation from this one, and on subtraction the signs will change. This will be to minus, this will change to plus, and this will also change to plus. This x part will cancel out. So, I have 17y equals 153, which gives me the value of y as 9. So, having obtained the value of y, what do we do then? We have to get the value of x, and to get the value of x, what do? We substitute the value of y in one of the equations. So, let us substitute that value in one of the equations. So, one of the equations is 9x minus 8y equals minus 27, and because we found the value of y to be 9, so that becomes 9x minus 8 times 9 equals minus 27. So, here 9x minus 72 equals minus 27. Transferring this minus 72 onto the right hand side of equality, we get 9x equals minus 27 plus 72, which is 45, and therefore, the value of x comes as 5. Now, recall what was the fraction. In the fraction we had supposed numerator to be x and denominator to be y, and we have already calculated the value of x and y. So, therefore, our original fraction was x upon y, and that is equal to 5 upon 9. So, the fraction is x upon y equals 5 upon 9. So, here you saw one of the practical problems of mathematics involving fractions. Let us have another problem. The fare from Delhi to Allahabad is 900 rupees for 3 full tickets with reservation charges, and for 4 children below 12 years of age along with reservation charges, it is rupees 680. Further, if the fare for a child is half the fare of the full ticket if the child is below 12 years of age, but the reservation charges are same, then what are the reservation charges and the price per ticket? Now, here what are the variables? The one is the fare and the other is the reservation charges. So, what we will assume? Let the fare for the full ticket be x and the reservation charges be y. Now, for 3 full tickets, the fare for 3 full tickets will be 3x and the reservation charges will be 3y. Now, the cost of the ticket has to be added to the reservation charges. So, 3x plus 3y makes it 900. Now, in the second condition, it was provided to us that the fare for a child below 12 years of age is half the fare of the full ticket. So, the fare for half a ticket will be x by 2, and since 4 children are there, so this will be 4 times x by 2, but the reservation charges are same. So, that will be 4 times y equals 680. Now, look at these equations very carefully. In the first equation, we have 3 as the common factor. So, we can divide the first equation by 3, because on dividing a equation, the equation does not change. So, on dividing the first equation by 3, I get x plus y equals 300, and the second equation I will divide by 2. So, that makes it x plus 2y equals 340. So, we got these two equations, and now I need to find out the values of x and y. And how do I go for that? The values of x and y can be found out by solving these two equations simultaneously. See the equations once again. The first equation is x plus y equals 300 and x plus 2y equals 340. From the first equation, I get x equals 300 minus y, and from the second equation, this x plus 2y equals 340, I get x equals to 340 minus 2y. Now, we got the value of x from both the equations. Now, eliminating this variable, we get 300 minus y equals 340 minus 2y, and now transferring the constant terms onto the right hand side by equality and variables onto left hand side, I get minus y plus 2y equals 340 minus 300, and that will give me y equals 40. Now, can you tell me what y was? Y was the reservation charges. Now, I am supposed to find out the cost of the ticket as well. So, for that I will make use of one of the equations. Let me make use of the equation x plus y equals 300. The value of y, which is representing the reservation charges, that has been found out as 40. So, substituting this value, we get x plus 40 equals 300, and therefore, x is equal to 260. And now, you can very well make out that what is the cost for full ticket? The cost for full ticket is rupees 260, and the reservation charges are rupees 40. But since the half ticket, that is the ticket for a child below 12 years of age, is half the fare of the full ticket. So, therefore, the fare for half ticket will be 260 divided by 2, and that is equal to 130. And now, a short while ago, we had discussed that after you have solved the problem, you must see whether it satisfies the given conditions or not. So, let us see, we have found out the fare for full ticket as 260 and the reservation charges as 40. Now, we had 3 full tickets. So, that means 3 into 260, added to it the reservation charges for 3 tickets. How much that comes to? That is 780 plus 120, and that is equal to 900. So, this is satisfying the first condition. And what was the second condition? 4 tickets, 4 half tickets. So, 4 into 260 by 2, that will be the price of fare for 1 ticket plus the reservation charges for 4 tickets, that is 4 into 40, that will be equal to 520 plus 160, and obviously this total comes out to be 680. So, after having solved this, now we are sure that our calculation is correct, that is the fare for the full ticket was rupees 260 and the reservation charges were rupees 40. So, let us take now another problem which concerns about the area of a rectangle. The question goes like this: if the length of a rectangle is reduced by 5 units and its breadth is increased by 3 units, the area gets reduced by 9 square units. But if the length is increased by 3 units and the breadth is increased by 2 units, its area gets increased by 67 square units. Now, having seen the problem, what do you feel are the unknown quantities over here? The unknown quantities are the length of the rectangle and the breadth of the rectangle. So, what we will assume? We will assume the length to be, we can take it as x or any other variable. Here I will take the length as L and the breadth of the rectangle I will take as B. Now, when the area of the rectangle, when the original length is L and the breadth is B, the area of the rectangle is length times breadth. So, that will be L times B, that is equal to L B. But the first condition was that the length is reduced by 5 units. Now, what is the original length? Original length is L. On reducing it by 5 units, the new length becomes L minus 5. And the breadth is increased by 3 units. What is the original breadth we have supposed? B. Now, it is increased by 3 units. So, increasing means to original breadth I will add 3. And what is happening to area? Area is decreased by 9 square units. So, original area is L times B. Because it is decreased by 9 units, so I will subtract 9. Now, we will equate this new area. The new area will be L minus 5 into B plus 3 equals new area, which is 9 square units less than the original area, that is L times B minus 9. So, having found one equation, we will have to simplify this equation to get a linear equation in L and B. How do we go for that? Let us see that. This is L minus 5 into B plus 3 is equal to LB minus 9. Now, on expanding this, we will get L times B into L times 3, that is plus 3L, minus 5 times B minus 5 times this 15 is equal to LB minus 9. Now, here LB, this quantity and this quantity, they are existing on both sides. So, this we can cancel out. So, we get 3L minus 5B equals minus 9 and minus 15 transfer to the right hand side, this will become plus 15. So, first equation we get is 3L minus 5B equals 6. So, this is the first equation we got from the first condition. Now, we had the other condition also. What was that? The other condition was the length is increased by 3 units. on increasing the length by 3 units, we get L plus 3, and increasing the breadth by 2 units, we get B plus 2. The area increases by 67 square units. So, the original area is L times B plus 67, and from here the area of a rectangle is given by length times breadth. New length is L plus 3 times B plus 2 equals LB plus 67. Now, this can also be simplified. Now, when we expand this side, we get LB plus 2L plus 3B and plus 6 equals LB plus 67. Again, LB onto left hand side is positive quantity, and here it is also positive quantity, that can cancel out. So, we get the final equation as 2L plus 3B equals 67 minus 6, and 67 minus 6 is how much? That is 61. So, we got two equations as 3L minus 5B equals 6, and second equation as 2L plus 3B equals 61. Now, we have to eliminate one of the variables, that is one of the unknowns. Now, here I decide to remove B first and evaluate the unknown L first. For that, I will multiply the first equation by 3 and second equation by 5. Can you make out why I am multiplying the first equation by 3 and second equation by 5? Because to eliminate B, I will have to make the coefficients of B in the first equation and in the second equation same. So, multiplying the first equation by 3, I get 9L minus 15B equals 18, and the second equation is 10L plus 15B equals 305. Now, the coefficients of B have been made same, that is minus 15, this is 15 and plus 15, and their signs are opposite, one is minus 15 and other is plus. So, what do? We add these two equations to cancel out B. So, I get 19L equals 323, and from there I will get the value of L as 323 divided by 19, and that is equal to how much? And 7. So, having got the value of length, which was one unknown, I have to get the value of the other variable, and for that what do? I put the value of this length L, value of L, in one of the equations. So, 3 times 17 minus 5B equals 6, and that will give me 3L 51 minus 5B equals 6. Solving it further, I get minus 5B equals 6 minus 51, and that is equal to minus 45, and the value of B then comes to be, the value of B comes out to be 9. So, here we got the value of length as 17 units and that of breadth as 9 square units. Let us have a check for this. How do we go for check? The check is performed by putting the values of length and breadth in one of the conditions. Length we have calculated as 17 and breadth 9. So, what is the original area? The original area becomes 17 times, original area is 17 times 9, that is 153 square units. Now, recall what was the first condition. First condition was the length is reduced by 5 units. So, new length is 17 minus 5, and the breadth was increased by 3 units. So, that means the new breadth will be 9 plus 3, and that is equal to 12 times 12. This is the new area, and new area becomes 144 square units. Now, in the problem it was already stated that when length is reduced by 5 units and breadth is increased by 3 units, the area is reduced by 9 square units. Let us see, does it satisfy that condition? The original area is 153. Now, when 153 original area is reduced by 9 square units, we get 144 square units, which is same as the value which I have calculated. So, this is the way we go for the problems concerning the area of a rectangle. Here once again I remind you that we go for the unknowns in the form of variables, that is, in the last problem we took the length as L and breadth as B. It is not always necessary to take the unknowns as X and Y. Now, let us see another problem. Now, in this problem this concerns about a classroom. Now, in a class, if 3 students sit on each bench, then 6 students are left. But if 4 students sit on each bench, then 2 benches are left. Find the number of students and the benches in the class. Listen to the problem once again. In a class, if 3 students sit on each bench, then 6 students are left. But if 4 students sit on each bench, 2 benches are left vacant. We have to find out the number of students and the number of benches. Now, here what is the condition now? The condition here is that the benches and the students both are not known to us. So, what we will do? We will suppose the number of benches to be X and number of students to be Y. Now, if 3 students are sitting on each bench, then the number of students which will sit on X benches will be 3x, but in that case 6 students are left over. 6 students are left over. So, that means if we add to it 6, I get the total number of students. Listen to this once again. If 3 students sit on each bench, that means the total number of students sitting on benches will be 3x, but 6 students are left over. So, that is 3x plus 6, and number of students I have already supposed as y. So, that becomes 3x plus 6 equals y. But if 4 students sit on each bench, 2 benches are left over. So, that means original benches are x and 2 benches are left over, that is new benches will be x minus 2, and because 4 students are sitting on each bench. So, this is 4 times x minus 2. This will be equal to number of students, and on simplifying this I get 4x minus 8 equals y. So, we got 2 equations, the one 3x plus 6 equal to y. Now, here I have equated the number of students to the total number of students supposed, and here also I have equated the number of students to the total number of students. Now, these equations can be solved by the methods which have already been taught to you. So, today viewers, we saw that how the simultaneous equations are applied in word problems, that is practical problems which involve known and unknown quantities. You also do practice for some of these questions.